Hello friends, in the previous class we discussed about atoms and then we discussed about different philosophers how he represented the atom. Then we discussed about law of chemical combination like law of conservation of mass, law of constant proportion. Then in the next class we discuss about Dalton's atomic theory. So today in this session we will discuss about atoms in details. Before that, if you are all are new to this channel, so don't forget to subscribe it and press the bell button for further class notification. So let's start. So today we'll discuss about atom. So imagine an ant hill. It is made up of small grain of sand. It means here, look, this picture is a picture of ant hill. So this ant hill is made up of small grain of sands. So if you consider this ant hill as matter, then this small sand grain of sands will be what? Atom. So just like that, the building blocks of all matters are atoms. So in the next slide, how big are atoms? So if from previous slide, what we learned that the atoms are very small. Just like if we imagine it as matter as ant hills, then the small grain of sand will be what? Atoms. So atoms are very small in size. If we stacked more than millions of atoms in a layer, then it would make a layer barely as thick as the sheet of paper. It means what? If we stacked one after another, 10 lakh atoms one after another, then we will form what? A thick sheet of paper. Means you just imagine how small these atoms are. So here atomic radius is measured in nanometer. Nanometer 1 meter is equal to 10 to the power 9 nanometer. That means 1 nanometer is equal to 10 to the power minus 9 meter. So just imagine how small is this. So modern day symbols of atoms of different elements. So here Dalton's was the first to use this type of symbols. One symbol represented one atom of that element. Here just look in this table. Here elements are given: hydrogen, carbon, oxygen, phosphorus. Just like elements and Dalton's proposed symbol also mentioned here in this side. So if suppose I will, if suppose we consider about hydrogen. So suppose we are conducting an experiment and we have to write hydrogen. So it will take much more space, much more time to write this hydrogen, helium, argon, this. So Dalton told that no, there is no need to be write hydrogen in this way. We have to represent this as like this circle and one point at the center of it. So he gave this type of, for hydrogen this, and for carbon he told that to make just circle and darken the circle completely. This will be considered as for carbon. So he gave many symbols for different elements, and the symbols are different from one another. But later some scientists found this is also difficult, because for different element you have to remember different symbols. So to remember symbols, it is not easy task. It was not easy task that time. Let's that time, this time also, if I will tell you, just remember for hydrogen this symbol, for helium this symbol, for then for 118 elements you have to remember 118 pictures. So just imagine how much difficult it to remember this thing. So Bergelius, another scientist, suggested that the symbols of element be made from one or two letters of the name of the element. Means he told that why to remember all the symbols. Just took the first one or two letters of the name of that element, and that will be the symbol for that element. So the name may be taken from the places they were found, like copper. Copper was taken from Cyprus, Cyprus area. Copper. This name was taken from what? Cyprus, or from specific colors like gold meaning yellow. So gold name taken from where? Yellow. Yellow means yellow color. That yellow color considered as gold, means yellow name is considered as gold in that area. So as it look yellow in color, so we name gold as we named gold because of his yellowish color. So, IPAC, International Union of Pure and Applied Chemistry. Just remember this full form, most important. Is an international scientific organization that approves the name of symbols, elements, and unit. So, who decided the name? International Union of Pure and Applied Chemistry. This organization this organization decided what will be the name a, of an element or unit or symbols. The first letter of a symbol is written as a capital letter, and second letter as a small letter. So just look at the periodic table here. Hydrogen capital, then lithium, look, L is capital and I is small. At beryllium, B capital, E small. Magnesium, M capital, G small. So just like that, we have to write first letter as capital and second letter as small. So symbols of some elements are taken from its name, that may be English, Latin, German, and Greek names. Not just only English name, the name taken from Latin, German, and Greek also. So example, chlorine, Cl, iron taken from name ferrum, F-U-R-R-U-M, ferrum, means in some region, in some language, Latin or German, it is considered as ferrum. So from the ferrum, first two letter Fe, one is capital and another is small. So sodium, in some language it is called as natrium. So capital N and a small a. Okay. If you have any problem, just tell me in the comment section. I will discuss in the next class of mine. So don't worry for that. Okay. So in the next class we will discuss about atomic mass in details. So before that, if you like the video, then just give like button, and again, if you are new to this channel, just subscribe the channel. So thank you. We'll meet in the next session. Thank you so much.